Welcome to the SF Crow's Nest Future Focus podcast, where we take a closer look at some of the most interesting and innovative technologies shaping our world. Today, we talk all things airship, and not just any airship, but the world's longest aircraft, the Airlander. It's been a bumpy ride for the Airlander, but it's finally on its way to transforming the travel landscape. First, let's talk about the Airlander's unique features. It's a hybrid airship that combines aerodynamic and aerostatic lift, and it's powered by 4 diesel engine-driven ducted propellers. With its helium airship and auxiliary wing and tail surfaces, it's capable of flying for up to 5 days while crewed and over 2 weeks while unmanned. But what really sets the Airlander apart is its ability to land on any reasonably flat surface via 6 inflatable studs, meaning no more airports. And with a top speed of 100 miles per hour, the Airlander moves at a leisurely pace, making boarding and security protocols more like boarding a ferry or train. Now, you may be thinking, 100 miles per hour isn't very fast. But when you factor in quicker boarding times and remove airport congestion, the overall journey time is comparable to a short-haul flight. Plus, the Airlander has a maximum capacity of 100 passengers, meaning a more exclusive and luxurious experience than a typical Boeing 737-800, which carries 189 passengers. The Airlander 10 is powered by a total of 4 Thielert Centurion 325 horsepower V8 diesel engines, which drive sets of 3-bladed ducted propellers to provide the thrust for both flight and maneuvering. These engines are positioned in pairs, one set being located towards the rear of the airship, while the other is positioned alongside the sides of the forward fuselage, mounted on stub wings. Each engine is furnished with a 67 horsepower generator, which provides electrical power for the airship and its mission systems. The assembly for each of the side-mounted engines can be pivoted 20 degrees in either direction, vectoring the thrust to provide flight control, particularly during landing and taking off. The rear-mounted engines are fixed. By employing thrust vectoring, the engines can direct their thrust downwards to provide additional lift during takeoff. A series of 4 triangular-shaped variable vanes are positioned behind the engines to provide further control authority by redirecting thrust from the rear engines over the tail fins. While cruising at altitude, propulsion can be switched to a more efficient electric drive fed from the airship's central generator. Due to the hybrid aerostatic aerodynamic lift approach, fuel can be expended without entering a state of positive buoyancy that would necessitate routine helium venting in order to land, a costly weakness present upon conventional airships. Fuel is primarily contained within the 12-meter-long main fuel module, housing up to 9 tons of fuel. The main tank is supplemented by separate rear and forward tanks, containing up to 4 tons. To optimize cruising efficiency, the angle of incidence can be adjusted by pumping fuel between the fore and aft tanks. The flight deck of the Airlander 10 is quite spacious and features 4 large floor-to-ceiling windows that offer excellent external visibility. Although the airship was initially designed to operate without a pilot, HAV eventually installed positions for a single pilot and an observer in response to customer interest. In the future, the company plans to introduce a twin-pilot configuration and replace traditional controls with more advanced glass cockpit-style controls and instrumentation. The Airlander 10 is controlled using a side stick mounted on the right-hand side of the cockpit. There are no rudder pedals as the side stick is automatically slaved to the vanes. The avionics suite is supplied by Garmin and includes a closed-circuit television system that enables the pilot to observe the engines. The flight control system of the Airlander 10 is connected to the propulsion units and flying surfaces through fly-by-optics technology. This system uses optical fiber cables to efficiently handle the vast scale of the vehicle. The pilot's controls are switches and potentiometers that produce digital signals encoded into light pulses and transmitted to the appropriate equipment using 11 FCS satellites located around the vehicle. The flight control system regulates the transition between the vehicle's different modes of flight, allowing it to be operated locally, remotely, or in an unmanned configuration. HAV states that the natural pendulum stability of the airship made it easier to design the flight control system. But what is the passenger experience like? Well, it's more like traveling on a cruise ship than a plane, with a cabin that feels more like a compact hotel than a flight. The Airlander has 8 ensuite bedrooms sleeping 16 passengers, a bar area with wine glasses hanging confidently from above, mood lighting, and a coffee machine. It's quiet in the cabin too, and passengers won't have to worry about turbulence experienced on planes. And get this, you can even open the windows. The Airlander offers a tantalizing possibility for luxury cruise operators with no restrictions on where the aircraft can take off and land, and with the capacity to stay in the air for up to 3 days. We could see the arrival of aerial safaris above the Serengeti, and immersive northern lights experiences in the high Arctic. Places unconnected by roads suddenly become accessible. But the real selling point of the Airlander is its sustainability. It produces between 75 and 90% less emissions per passenger per mile than a plane, and the potential for reaching net zero is real too. The supersized aircraft has the capacity to be kitted with electrical motors and hydrogen fuel cells once the technology becomes readily available. The Airlander is poised to become the perfect example of how luxury and sustainability can coexist. So, what's the verdict on the Airlander with the editorial team here at SF Crow's Nest Towers? Well, we think it's a game changer. Despite its bumpy start, the Airlander has proven its resilience and potential to transform the travel landscape. With its luxurious and sustainable features, we can't wait to see what the future holds for this majestic airship.